And as I'm sure you all know, we'll go over PRC-29-1, which are the frequency and voltage ride-through resources. So as we get into this, I'm just going to introduce PRC-29-1. We'll go over the applicability, core requirements and measurements, compliance, and then any questions. And I'll also stop in the middle for a round of questions as well. Before we get started, here are just some abbreviations that are used throughout the presentation. All right, let's get into it. So PRC-29-1 was born from FERC Order 901, which was essentially a direction to NERC to develop new or modified reliability standards that require registered IBR generator owners and operators to use appropriate settings. FERC Order 901 had a lot of new standards in it, and PRC-29-1 is just one of those standards under that umbrella. And it's significant because it's the first real formal recognition that IBRs are now critical reliability assets from FERC. The purpose of this was to ensure that IBRs ride through to support the BPS during and after defined frequency and voltage excursions. Why this is so significant is right now, currently under the PRC 24-3 standard, the expectation is that IBRs just shouldn't trip. And this is going to shift that expectation to not only should they not trip, but they have to actively support the BES. So why do we need a new standard? Over the years, IBRs have exhibited performance issues in the field, and these performance issues were not seen in common synchronous generators. And it was determined that these were compromising the BES, so that's why FERC ordered NERC to come up with this new standard. So NERC enforces three major types of reliability standards. There's performance, which has narrow scopes of definitions. And then you have objective and risk, which are larger scopes and broader responses. So right now, PRC 24-3, which IBRs fall under, was actually designed and intended for synchronous generators. And it's not a performance-based standard at all. And we will keep that standard. It's going to become PRC 24-4, and it will still apply to synchronous generators. But PRC 29-1 is a standard that was built off an existing IEEE standard, IEEE 2800, and it's a new performance-based standard to ensure ride-through for the expected BPS disturbances. So here's just a timeline of what happened and where we're at and where we'll be at in the future. So as I mentioned, there were a series of issues that have happened over the past decade, disturbances like the Blue Cut fire, Canyon 2 fire. These all showed that IBR penetration was becoming an issue as more IBRs came onto the grid. They were compromising the bulk electric system. So FERC said, hey, we need to do something about this. And on July 27th of 2023, they issued Order 901. Which was essentially, as I mentioned, it was an instruction to NERC to create a myriad of reliability standards to address IBR risks. And under that umbrella was PRC 29-1, which essentially was the foundation for the legal framework from which PRC 29-1 is built from. So a little over a year later, towards the end of 2024, NERC, after many rounds of technical discussions, filed PRC 29-1 standard with FERC with a proposed effective date of October 1st, 2026. Short while after that, in 2025, FERC issued Order 909, which was the approval of PRC 29-1, but it imposed additional conditions and expectations and addressed many concerns that NERC actually had. So NERC responded and said, hey, should we still have this October 1st deadline? And they held a bunch of public workshops and addressed mainly these issues of hardware limitation concepts, which were creating a lot of questions. FERC responded and said, yes, like October 1st, 2026, you can still meet it. So that's the date. That's the effective date that's still in place despite this Order 909. So the applicability, pretty straightforward. Any generator owner, all BES IBRs, and if it's a non-BES IBR, if you have or contribute more than 20 MVA, and your voltage at the POI is greater than 60 kilovolts, PRC-29-1 applies to you. All right, so what criteria need to be met, and how can we prove that we are meeting those criteria? So there are 4 requirements, and I'll go through those in detail right now. Requirement R1 is the voltage and ride-through capability. This is fairly similar to what is in place right now with PRC 24-3. And it says that each generator owner shall ensure the design and operation is such that each IBR meets or exceeds ride-through requirements in accordance with the must ride-through zone as specified in attachment 1. Notice the bold there on the design and operation. You see this throughout requirements 1, 2, and 3. And it's a very important concept within PRC 29, which I'll cover in a little bit. Conditions where disconnection is allowed, fault clearing and disconnection. So clearing faults has a priority, and some faults cannot be cleared unless the IBRs disconnect. The second exception, the voltage at the high voltage side of the MPT went outside hardware limitation. So existing IBRs that were built before this standard is implemented could be pushing the voltage and frequency outside of the limits, and it could actually damage the inverters. NERC doesn't expect equipment suicide, so essentially what they're saying here is, go ahead and shut these off if you absolutely have to, but or you cannot abide by this standard if you absolutely have to, but it's going to be needed to be documented and in accordance with requirement R4. And number 3, large phase angle difference between the high voltage side of the MPT and the inverter terminals. This one's quite technical, but essentially non-fault switching events can cause sudden jumps in phase angle, which can disrupt the logic within the inverter. And what NERC is saying here is that stability and control integrity has greater priority than fault ride-through. And then number 4, prolonged volts over frequency exposure. This essentially causes magnetic saturation, which can damage equipment like the main power transformer and other very expensive equipment on the bulk power system. So how do we measure this? How do we show this? How do we prove that we're in accordance with requirement R1? Dynamic simulation studies, plant protection settings, control settings, and design evaluation are all used to prove that design portion of the definition. And then as far as the operation portion goes, you need to retain evidence of actual disturbance monitoring to demonstrate that IBRs meet R1 standards. So if you do go through one of those voltage ride-through zones or zones of high voltage or low voltage, and your IBRs ride through, you need to be able to prove that through the data that you collect. And then ride-through exemptions utilized within the must ride-through zone in accordance with point 3 above must have evidence retained to demonstrate the IBR failed to ride through. All right, requirement R2. This is where PRC 29 kind of shines. This is where that performance-based standard really comes into play here. So R2 says that each generator owner shall ensure the design and operation is such that the voltage performance for each IBR adheres to the following during a voltage excursion. So there's 3 regions of operation, and we'll go over those. Like we'll look at attachment 1, which will go over these voltage limits shortly. But essentially, you have a continuous region where this is the region of normal operation where you continue to deliver real and reactive power. And then you have a real or reactive power prioritization. Usually this is reactive power. Once you exceed a voltage threshold, this could be low voltage or high voltage, you can enter the mandatory region, which each IBR shall exchange current to maintain voltage on affected phases. That effect could be either symmetrical or asymmetrical faults, and again, under reactive or real power priority. And then permissive region. This is just for really low voltages. Each IBR may operate in current blocking mode. So this is momentary cessation to avoid tripping. Otherwise, just enact the same requirements for the mandatory region. Now, if the IBR does have current blocking mode, there is a requirement that once the voltage stabilizes on the high voltage side of the transformer, current exchange mode needs to be entered with less than 5 cycles. And performance expectations. So as IBRs move from that mandatory or permissive region back into that continuous normal operation region, essentially you can't have heavy overshoots that are going to push the high side of the main power transformer outside of its voltage limits. And then when they do come on and they restore real power, it needs to be restored to pre-disturbance level or the available level, whichever is less, within 1 second. And again, measurement for this is pretty similar to R1, dynamic simulation studies, plant protection settings, control settings, and design evaluation to prove that design portion. And as far as the operation goes, just retain evidence of actual disturbance monitoring. In areas of exceptions, so this is typically going to be if you have a real power prioritization. If you recall, I noted that typically your facility will be in a reactive power prioritization mode, but some TOs or TPOs could require that it's real power for whatever reason, and you need to retain all evidence of that. So email exchanges, contact information, whatever. So here's attachment 1. Essentially, it ensures equipment survivability during deep voltage excursions. If you look over here, you have this continuous region right here. This is that kind of normal operation region, and then you have your mandatory, and then at that real low voltage, you have your permissive. Note that there are 2 tables here. Table 1 is for type 3 and type 4 wind resources, and then table 2 is for all other IBRs. All right, requirement R3, frequency ride-through. Very similar to requirement R1, except it's for frequency instead of voltage. So the definition is specific obligations of IBR's frequency ride-through in response during a frequency excursion event. So your facility is going to be required to ride through defined bounds, which I'll define in the next slide. Rate of change of frequency needs to be less than or equal to 5 hertz per second. And hardware limitations can apply, but again, need to be approved within requirement R4. Very similar measurements, dynamic simulation studies, plant protection settings, etc. Retain evidence of your actual disturbance monitoring. Again, any frequency disturbances that happen on the grid, if they come in and do an audit, they're going to want to see that you were recording the data during that event. And in areas of exceptions for performance requirements, GO to retain all evidence. So here's attachment 2, which defines the must ride through and may ride through zones for requirement R3. Again, measurements at the HV side of the MPT must be taken in 3 6-cycle periods. So you can't use instantaneous points of measurement. And time is cumulative. Ride-through durations are accumulated over 1 or more disturbances within a 10-minute window. So this window will shift. And I forgot to mention actually that for the voltage, it's the same, except it's a 10-second window. And so requirement R4, I imagine there's going to be a lot of concern here. So we'll try and unpack everything carefully. NERC has been given a really long leash on this by FERC. And they've also addressed this requirement in meetings more than any other requirement, which I'll address here. But first, let's just go over the definition and how it's implemented. So definition is existing IVRs may be exempt from certain ride-through criteria only when a true non-fixable hardware limitation exists. So when can this be used? Well, any of those 3 requirements that I just listed above, R1, R2, R3, your IVR cannot meet them, and the limitation is due to physical hardware. That is to say, it can't be fixed in software, and to actually solve the issue would require a hardware replacement. So in order to prove this, it's just a matter of documentation, and the types of documents you need are identifying information of the IBR. This could be the name and the facility number, which requirements cannot be met, and the current capability due to that limitation. The specific hardware causing the limitation, this is typically just going to be the IBR itself. They don't expect you to go in and say, like this capacitor within the IBR is what's causing this. Number 4, technical documentation that supports the claim of the hardware limitation. This could be OEM curves, damage limits, etc. And any information on hardware remedies that may be in place if available. Of course, this isn't necessary, but if you have a facility and you are planning on upgrading it, just make that information available when you submit your documentation. How do you communicate this? Yeah, there are strict requirements around this as well. So submission to PCs, TPs, TPOs, RCs, and CEA within 12 months of the PRC-29-1 effective date. Again, that's October 1st of this year. Provide any requested additional information from listed entities within 90 days. So in that initial submission, you could get a response from any one of those entities, and you just need to reply to them within that time period. And then once you are accepted from the PCs, TPs, TPOs, RCs, just provide the CEA with an acceptance letter to the other entities within 90 days of receiving that. One important note too, when you go out for collecting this documentation, sometimes OEMs are going to say, hey, this information is proprietary or it's confidential, we can't share it. This only needs to be submitted to the CEA. So those other entities won't actually need that. And hardware changes. So when you do make changes, you need to notify the PC, TP, TPO, RC, and CA within 90 days of that change, and your exemption will no longer apply. Again, as I mentioned, the way to measure this, just documentation and evidence of your communication. All right, we'll move on to compliance, where we'll talk about what criteria need to be met and how we can prove that we are meeting that criteria. But before we do that, I do want to just stop here and ask if there are any questions before I move on.
Yeah, so you need to have models showing that. Do you need those models for existing sites, those like transient type models, or is that just for new sites that are being built after a certain day?
No, every facility is going to be required to follow PRC-29 come October 1st, 2026. So you'll need to have models that will prove that it rides through.
Okay.
Hey, Jesse, I have a question for you.
Yeah.
So how does NERC define in-service for IBR?
Yeah, that's a good question. So in-service is going to be, there was a lot of discussion around this. I went to a number of talks and conferences about this. This is for hardware limitations that are already in service. So let's say you have a facility that you're building right now, and it's not going to be online come October 1st, 2026. That's okay. It seems like you'll still be able to get your hardware exemption if you have hardware that's not going to abide by the standard. So what NERC really means by in service, from what I gather, is that you have a GIA and there's been some groundwork laid. They don't expect you to just lose all your money on this just because of the standard. Yeah, thank you. All right, if that's everything, I'll move on to compliance. So we'll discuss R1 through R3 first, since they're a little bit separate from R4. Again, just a reminder, across these requirements, these first three, you need design evidence, and then you need that operational evidence, so disturbance monitoring evidence. For voltage, you have a cumulative duration period of 10 seconds for the voltage must ride through region. So effectively what this is saying is that IBRs are required to withstand an unlimited number of disturbances that are spaced 10 seconds apart, must be proven in the model, must be proven if these events occur on the BPS. Same deal with frequency, except instead of 10 seconds, it's 10 minutes. So it effectively requires an IBR to withstand an unlimited number of disturbances spaced 10 minutes apart. So what sort of evidence do you need in order to show compliance? Requirement R1. Remember, it's just saying what the plant will not do. It's not going to trip during a voltage event. The evidence for this could be under voltage, over voltage protection settings, OEM ride-through capability curves, dynamic simulations, inverter design documentation. R3 is very similar to that. What the plant will not do, will not trip during a frequency event. So all the evidence is the same, except instead of under voltage and over voltage protection settings, you'll have under frequency and over frequency protection settings. And then R2, remember this is that performance-based standard. So what the plant is capable of electrically while riding through. And evidence for this can include inverter control block diagrams, dynamic simulations and models, voltage disturbance simulations, and any documentation for external instruction. For this, NERC has made it very clear that no EMT model is necessary, but you can have positive sequence models such as PSL for PSSE, and those will be sufficient. So that was the design for R1 through R3. Let's talk about compliance for the operation of R1 through R3. Event evidence is conditional, not constant. What this means is there's no need to cause or manufacture an event. But when an event does occur, you need evidence. The implications of this are that you need to have documentation too. Like even if you're in a low fault area where you could have an IBR resource that's never experienced a fault in its life, you still need to have documentation that shows that you're capable of monitoring disturbances at the right locations. And also, of course, retention of data when or if that event occurs. The retention period is 36 months for R1 through R3 and then 5 years for R4. Big takeaway from this is that design evidence is sufficient on its own until superseded by real-world events. So here we are back at hardware, R4. To comply with this, acceptable limitations are inverter or turbine designs whose internal components cannot tolerate required voltage duration, required frequency duration, required phase angle jumps. You could have a facility that has legacy equipment that's no longer manufactured, or the OEM is just completely out of business, no longer testable, not designed or validated for today's ride-through requirements. Or you could have physical component constraints that the OEMs explicitly state were never tested, because how would they have known PRC-029 was going to be in effect? And they can't be tested now and can't be resolved without redesign or replacement. I was on a call with GE, and they were talking about their wind turbines, and yeah, they made this very clear. Like, there's no way the current ones that are out there, they can't test them. So, and it takes a lot to set one of those windmills up in a lab and test it. And so, what are unacceptable limitations? Protection miscoordination, conservative relay settings, controller tuning choices, disabled features that you could have enabled, firmware versions that could be updated. So all of those have one thing in common. They're all software. Software is not hardware. Also lack of studies or models, and then of course, cost. Big takeaway on this one, NERC and FERC have both made it very clear, R4 is not an off-ramp for inconvenience. So this is just a list of foreseeable issues that could occur that I came up with. By no means is this list exhaustive. So the first, it could be wrong measurement location. Say you have the HV side of an MPT and then you have a 300-foot line just over the fence that connects to your POI, and you're monitoring the POI instead of the high voltage side of the MPT, you're going to be non-compliant. So just keep that in mind. Trip settings are made relative to the inverter terminals. Remember, everything is at the HV side of the MPT in PRC-029. So all that stuff doesn't matter. All those ride-through zones were at the HV side, and they need to be monitored there. Requirement 1 is proved, right? So you prove that you ride through, but what about your PQ priority? What about your current blocking exit time if you hit that really low voltage? What about recovering your real power within 1 second? And then Q ejection behavior if you're in Q priority. Well, those are all under R2, so you can have R1, but R2 can fail. And you need to be sure that you prove that it passes that requirement. Priority logic, R2 requires priority behavior in specific situations and allows external entities to specify alternatives, but you need to document the implemented logic and any external requirements. If you don't, you risk being non-compliant. Over voltage recovery, remember requirement 2.4 prohibits the IBR from causing voltage to exceed applicable thresholds. So again, just make sure in your models that these are sufficient. And then the last but not least, mistaking hardware issue for software issue in R4. Tuning is not a hardware issue. Software is not a hardware issue. They're going to look really close at this, is my inclination, and they've made that very clear. Before we wrap up, I do just want to read this because I found this to be one of the most important paragraphs in Order 909 regarding long lead time projects. So if NERC determines that extension of the exemption to long lead time projects is warranted, we suggest that it consider including unequivocal provisions regarding the necessary showing to qualify for the exemption, e.g. proof of executed interconnection agreements and executed design, procurement, and or construction agreements, and a clearly stated cutoff date for application to long lead time projects. Further, we believe that the issuance of this final rule should provide notice that going forward, entities should design IBR facilities to meet the ride-through obligations set forth in Reliability Standard PRC-029-1. And with that, I will open the floor again for any more questions.
Question on applicability. So we're obviously talking about a large portion of dispatchable battery type on the bulk electric system. Do these requirements also apply to non-dispatchable battery applications, inverter-based applications?
That are connected to the bulk electric system?
Yes.
Yeah, if they're connected to the grid, it applies to them.
Okay, thanks.
You're welcome.
For that one of the first slides in the second section, compliant.
Oh,
I think
the compliance?
Yeah, with the design. Yeah, right there. For that evidence, I think it sounded like you were saying those were are all of those required for each requirement? All those evidence bullet points, or is it just those are the possible ones that would meet that? I just want to be clear what's required for the evidence.
Yeah, it's a good question, and in the standard they just say that yeah, they just list out what could be used, but for sure they want dynamic simulations to show the design, and all this other stuff is just going to help you out with that. That was a good question because I kind of wanted that too, and then I went on some of these workshops with them, and they just made it very clear that dynamic simulations are going to be required, and you're going to want to submit any other documentation for the inverters as well.
Okay, thank you.
Yeah, you're welcome.
Yeah, I have a quick question. So, if we're a client of yours and we're designing new facilities, we're going through the 30, 60, 90% design phase and stuff. Can we coordinate with you on ensuring that our design going forward, and I'm relatively sure it will, but that it will meet the standard, and to make sure as we go through our design that we're applying the right types of tests to it to meet the testing requirements here?
Great question. Yeah, you can definitely rely on us for that. In fact, I'm in the middle of working on a tool right now that's essentially building the models and then running through all these tests at 10-second intervals for the voltage, 10-minute intervals for your frequency. And once a model is built for the facility, it would just be kind of like a one-stop shop PRC-29 tool where things can just get, we could just plot them, look at the outcome, make sure that it applies, and then we can submit your all necessary documentation on your behalf.
Thanks.
Yeah, you're welcome.
I have one more question. When I was trying to look through this previously, it seemed like there was some language that I wasn't totally sure of where I was talking about. It was trying to align it with PRC-28 equipment installations, which has different dates, and then kind of as a second round to that, it seemed like some dates were October 1st and then other categories were January 1st of 2027. So could you address those 2 points?
Yeah, that's something I forgot to mention. Category 2 has a different, it's not October 1st, 2026. I believe it is January 1st, 2027. And then as far as PRC-28, yeah, they're coming, I think that's April 1st of 2027, I think is the first requirement that's going to be in place. But yeah, you are right that the category 2 has a different implementation date than category 1. It will be January 1st, 2027. So what is that? 3 months after the category 1.
Okay.
And then your hardware, that R4 will apply, until January 1st, 2027. Or sorry, January 1st, 2028, because you have 12 months to submit your hardware requirement
Oh,
for
okay.
exemption. So for R4, did that answer your question, Alex?
Yeah, I answered most of it. It's just I was looking at our PRC-28 timelines, and I just wanted to make sure, because it's a little complicated, and it's like, well, 50% of these sites built before this date, and so some of the PRC-28s for some of our sites aren't required until January 1st of 2030. And so I just wanted to confirm, and like the PRC-29 is not trying to tie itself to when your PRC-28 equipment's installed. It's just October 1st or January 1st.
Correct.
Okay.
Correct. Yeah. And go ahead.
Hey, this is Kaylee. I'm Director of Compliance here at GridSme. I would also add that between 28, 29, and 30, they are overlapping a lot in their compliance dates. And for 29 and 30, they have to have the equipment designed. You actually have to have it installed. And so you're right in that these dates are very confusing, and they're going to depend on a couple of factors. One, if you're category 1 or 2. 2, depending on how you approached your registration. So when you mentioned the 50% of your fleet, that's going to be tied to whether you have one NCR as a company or if you have one NCR per facility. if you have one NCR per facility, the 50% design does not apply to you. And then the third caveat here for the changing of dates is going to be when you went COD. So depending on if your COD is in the future, if it occurred in the last year, or if it occurred prior to 2025, you are going to see a different date for your facilities. We do have a tool here at GridSme that I can input your information and I can send you a customized timeline for your facilities if that's helpful. And that would include PRC 28, 29, and 30, as well as all of the requirement breakdown. So for example, in PRC 29, R1 through R3 and R4 could have different timelines.
Okay. Yeah, that sounds interesting. Yeah, if you can connect with me after the meeting, that'd be great.
Yeah, that sounds good. If you send us an email, I could definitely look at your facilities and help you establish a timeline.
Thanks, Kaylee.
I have a quick clarification question. The under and over voltage settings and all that stuff, is that strictly for inverters, or is that also for the substation protection settings as well?
For the under voltage, over voltage, these protection settings right here.
Yeah. Is it for strictly inverter settings, or is it for
No, it's going to be for the whole facility.
the whole thing? Yeah, I just want to be clear. All right, thank you.
You're welcome.
All right, any final questions from anybody?
Hello, just one more question about the simulation models and tools. Looks like it's restricted to PSLF or PSSC. Can utilities require one of those tools as the only tool being acceptable? And then also if there is an equivalent tool like DSA, is that also acceptable from simulation perspective?
Yeah, any positive sequence model, it's going to depend on what region you're in. For example, if you're in WEC, you're going to need to submit PSLF. If you're in any of the other interconnections, you're going to need to submit PSSE, or if you're in ERCOT, TSAT or PSAT might be acceptable. But yeah, those are the big ones, and I think those are the only ones that are going to be accepted. I mean, you might get some regional entity that takes a PSLF model and converts it to Power World, and in that case, you could submit a Power World positive sequence model as well. Does that answer your question?
It does. I was hoping that requirement should be more open and make it up to interconnection customer to decide which simulation tool to use to show in evidence, and not been driven by utilities requiring one of three tools.
Yeah, I agree.
All right, well, if nobody has any further questions, feel free to email us any questions that you do have after the call. Thanks, everybody. Our recording will be uploaded to YouTube. We also have a few upcoming webinars. If you're interested, this Thursday we'll be doing a deeper dive into PRC-28. And then next Tuesday we'll be hosting our SIP and C webinar. I'll put the registration links in the chat so that whoever wants to sign up can feel free to. Thanks, everybody.
Thank you.
Thank you very much.
Thank you. Nice work, Jesse.
Thank you. Yeah, thanks everyone for coming.